Mr. Peabody. Turn this way back. Irrational numbers are what? We talked about them yesterday. Who remembers? They don't make sense because we just can't really wrap our brain around them. Grace, they are?
Numbers that don't have numbers to go into.
Well, there's square roots that don't work out. Okay, they are square roots that don't work. Okay, we've got the perfect squares that do. And again, let's just throw out a couple of those. But by the way, most square roots don't, because there's not that many perfect ones. Remember, you have the square root of 1, which works out nicely because it's 1. You have the square root of 4, which is 2. You have the square root of 9, which is 3. You have the square root of 16, which is 4. Square root, let's do one more, 25, which is 5. If you think about all the other square roots that fall between those are all irrational because they don't have an exact answer. And I think the book does a nice job when it does this. Okay, here's my square root of 1. Now let's put it on top. Here's my square root of 1. It is 1, right? Here is my 2, which is the square root of 4, right? These other, all the other square roots fall in between there. In other words, in between 1 and square root of 1 and the square root of 4 has to fall the square root of 2 and the square root of 3. So even though they don't make sense to us, you should probably have some sort of a good indication of what they are. And I think I'm going to, maybe they don't say what it is. Nah, no, maybe they do, maybe they don't. I guess they don't. Sometimes they tell you what it is. So you need to understand that if by some chance they would give you a problem like this, what is bigger, the square root of 2 compared to, I don't know, 3, you'd have to be able to say, well, I know that which one's bigger. Why? Jacob?
3's bigger.
Right, because the square root of 2 has to fall between what two numbers?
1 and...
Yeah, it has to fall between 1 and 2. And I believe the square root of 2 is like 1 point, what is it, 1.2 something? Let's find out.
1.2.
Did we do that yesterday? No, I don't want that, sorry.
1.7.
What was it?
I don't know, that was for the 3. 3 was like 1.7.
Let's just jot this down so you know. The square root of 2 is 1.414. Or close to. This is what we do in math when you don't have an exact answer. Instead of putting equal signs, we make equal signs that look like scribbles, which says is approximately 1.414. Means it's not exactly, but it's close enough. And the square root of 3, ladies and or gentlemen, is, I think that sounds right, 1.73, yeah. 1.732 if you want. But, okay, and those again are approximations, they're pretty close or whatever it is. That's good enough. Because the book is going to give you something like this. Write this down. Take a look. Arrange from least to greatest. I'll give my little abbreviation. 0, 1, square root of 2, 3/4, 0.5, and negative 0.6. Okay, if you're arranging them from the smallest to the biggest, it may not be such a bad idea to just kind of throw down a number line. You know you've got 1. Might as well put a 2 in here. Is anything going to be bigger than 2? I don't think so. A 2 here. And if you were kind of guesstimating where these things should be, I guess we have a 0 in there, don't we? Let's put a 0 here. Okay, we know we have a 0, so we can put it right here. We know we have a 1, so it can go right there. The square root of 2 we just talked about is what? 1 point, what was it I just told you?
1.414.
Okay, 1.414. So you know the square root of 2 is kind of close to be right here. 3/4. 3/4. Where would that fraction 3/4 probably fit? Sometimes it's good to think about it as a decimal or whatever. Jacob?
3/4 to 1.
Right. It's between 0 and 1. 3/4 is probably close to right here. 0.5. Evan, where's 0.5?
Before 3/4.
Well, it's the same as the fraction 1/2, so it'd have to fall right here. Negative 0.6. Where's that going to be? Gary?
Behind 0.
Behind who?
0.
Right. It's going to be, I mean, if I had a negative 1 here, it'd be somewhere like right about here. So there they all are in order. You'd have negative 0.6, 0, 0.5, 3/4, 1, square root of 2. If I asked you to express your age in an irrational number, what would it be? Your age would be close to the square root of what number do you suppose? Well, let's see. Is anybody's birthday today? Because if your birthday was today, we could be right on the number today. But you guys are how old?
13.
If you're 12 and 13, well, 12 is the square root of 144, and 13 is the square root of 169. Okay, so if you were halfway between 12 and 13, you'd be halfway between these two numbers, which is what? About 12. You could say, oh, well, like the square root of 167. Because any square root that falls between those two numbers will be irrational, because we only have those are the two perfect squares that go with two consecutive integers. Everything in between is going to be irrational. You know, if you're a little over 13, you could say I'm like the square root of 175 years old. The square root of 175. Isn't that exciting? Don't you get some sort of a warm, tingly feeling? I don't know. Oh, and here's a beautiful thing too. Check this out. Let's say, write this down because you'll need this. Let's say we know that squares, when you find the area of a square, what do you do? By the way, that's probably why they're called square roots and squares there. If this is 6 and this is 6, the area of that shape is, Peter?
36.
36, whatever, units squared or whatever it is. So that means, children, how about this? Check this out. Here's where it really gets exciting. If I know the area of this is 25, what does each side have to be in order to give me 25? Now, here, listen to this very carefully, because here's where you guys become algebra people. You are asking yourself, what same number times itself gives you 25? Which is, in math, what we call the square root of 25, which is the square root of 25, Smith, is 5. So, that's all well and good if we have some nice perfect square numbers at our area, but what if we don't? What if they tell you that the area of a square equals 10? So now you have to ask yourself what number times itself gives you 10. Ooh, that's what I said. Peter goes, that doesn't make sense, that's irrational. And I say, yes, it is irrational. What did we do over here? We took the 25 and found its square root. So that's not 25 over here, it is 10, so it's going to be the square root of 10. The area of this is the square root of 10. Because you want to know what number times itself gives you 10. And it's an irrational number. It's not going to be perfect. It's going to be somewhere between, what, 3 and 4. Because 3 times 3 is 9, and 4 times 4 is 16. Probably closer to 3. But that's irrational. And you gotta, that's what we know all about. Yes, Jacob?
So if we get an irrational number when we're adding up the area, and it wants us to do the roots, if it's a irrational, you just put the 10.
Yeah, you put the square root of 10.
Yeah.
Okay. Now, they might ask you, for example, did they show some calculators things? You know, if it has a calculator next to it, you probably won't have to actually do it. calculator's not really believe them at this point here. But they might ask you this. Let's say you've got a square and its area equals, well, let's just say its area is 75. You know that each side then would have to be what? What number times itself gives you 75? It's not, there is not one, so if there's not one, you have to use the irrational thing, which is?
75.
Yeah, that's the square root. It equals the square root of 75. But if I asked you, what two numbers would the square root of 75 fall between? In other words, to give me a good guess, the square root of 75 is close to what two real numbers that we use? What two numbers do we use is the square root of 75 close to? So then you got to start thinking, oh, what are my perfect squares that 75 is close to? What times what would give me close to 75? Calvin says, all right, he says 8 would be one because 8 times 8 is 64, so the square root of 64 is 8. And he said 9 would be the other one because 9 times 9 is 81, so the square root of 81 is 9. Which one do you suppose it's closest to? It is going to be between 8 and 9. Is it closer to 8 or is it closer to 9? That's interesting. Oh, it'd be closer to, Evan?
9.
Yeah. And again, so you could, in the mathematical world, you could say, oh, this is approximately 9. And that would be probably good enough. So welcome, children, to the world of kind of algebra, sort of. Well, really, some of this stuff is more the pre-algebra stuff. You, by the end here, will be